Okay, let us move on to the scenario 2. The scenario 2 is nothing but time disparity. That is difference in timing or pattern of cash flows of the alternative proposals. Okay guys, so that is the flow of the cash flow will be differ. The cash flow will be more in the initial period and it may be decreasing over the end of the periods. Okay, let us move on to the steps. Okay, so the first step here is terminal value of cash inflows to be found by us. Okay, you're going to find the terminal value of cash inflows. The second step is modified net present value of terminal value is to be computed. Don't worry, modified net present value will be detailedly seen in the upcoming videos. Okay, so modified net present value of terminal cash flows and the modified IRR, you have to find all these three steps. So your terminal value of cash inflows is nothing but summation of cash flow into 1 plus r power n minus t, and your terminal unmodified NPV of terminal value is nothing but terminal value into 1 divided by 1 plus k power n minus initial investment, and your modified IRR is nothing but terminal value divided by initial investment power 1 by n minus 1. So the very important thing to be noted here is, instead of taking the cash flows, I'm just going to arrive with my terminal cash flows, and with the help of that terminal cash flow I'm just going to find my modified NPV and modified IRR. So this modified NPV and this modified IRR will be providing us with the same answer. There will be no confliction of selecting the proposals. Okay, here this n is nothing but number of years and t is nothing but the nth year, and this ia is nothing but your initial investment, and this k is nothing but your cost of capital. And very important point to be noted is, this r is not your rate of return or the cost of capital. This r is your reinvestment rate. So if reinvestment rate is not provided, we can take the random rates and can work out the problem. Okay, so the very important steps are these three only. Just keep it in mind so you won't be having any difficulties while you're doing the sums in the examination. Okay, let's move further. So let us understand this concept better with the help of an example, guys. So let us take the two project A and project B. So the investment comes to be 2,20,000 for project A and 2,20,000 for project B. It is same, right? Yes. So in first year the project A yields 62,000, in second year 80,000, and in third year it is 1 lakh, and in the fourth year it is providing me with 1,40,000, whereas project B providing me with 1,42,000, 80,000, 82,000, and finally 40,000. The cost of capital, that is K, is nothing but your 10%. Okay, let us move on to the solution part, but before that just see, your investment are same, but come to your cash inflows year 1, year 2, year 3, year 4. What happens here is, the pattern of the cash flow differs in this project, right? Under project A, the cash flows are lesser at the initial period, like year 1 it is 62, as you go on, and year 2 it is increasing to 80,000. It is in an increasing pattern, whereas when you come to this project B, it is of a decreasing pattern. So this is called as time disparity. Okay, let us move on to the example, guys. So the first step, what is the first step? First step is nothing but computation of terminal value. Very important to be noted here is, you are going to use the reinvestment rate. Okay, this terminal value is nothing but your future value. Okay guys, so the formula for this is cash flow into 1 plus r the whole power n minus t is the formula for finding the terminal value. So this R is nothing but your reinvestment rate. Always keep it in mind. It is very important. Okay, let us write the format here. It is year cash inflows calculation part, and here arriving with your terminal value of cash inflows. So year 1, your cash inflow for project A is 62,000. The calculation part is nothing but I am just writing the formula of the terminal value. So I am just taking this reinvestment rate to be 14%, since it is not given in the question. I am just assuming that it is going to be 14%. Okay, so by substituting all these values in the formula, So already I said absolute terms this 4 is nothing but the number of years the cash flow is going to happen to us from the project. The answer I am getting is 91,886. Similar format for the second year and third year and again fourth year. In the second year I'm just using 4 minus 2 and third year I'm using 4 minus 3 and the last year I'm using 4 minus 4 which comes to be 0. Again I will be arriving with the same answer. So taking summation of all these, you will be having your terminal value of cash flow at the reinvestment rate. Let us move further. This is for project A. I'm just going to work the same format for the project B also. So here cash inflow calculation and terminal value of cash inflows. Okay, what happens here? So for first year it is 1,42,000, second year is 80,000 and third year it is 82,000. For fourth year it is 40,000. Again I'm just going to substitute the values in the formula, terminal value formula, then I will be arriving with what? Terminal value of cash inflow. So terminal value of cash inflow is nothing but the summation of all these values. Yes, finally I just arrived with 4,47,827. Okay, let us move on to the next step. Next step is nothing but I'm just going to find the NPV, that is computation of NPV for terminal value at 10%. Here I'm just going to use my cost of capital. In first step you're going to use the reinvestment rate, and in the second step, and what I'm just going to use, I'm just going to use the cost of capital. Okay, net present value of project A. So net present value of project A is nothing but net present value for terminal value. We have to take the terminal value here. It is 4,49,854 into 1 plus R whole power n. Here R is your cost of capital, that is 10, minus your initial investment, it is nothing but 2,20,000. So by solving the same, I am arriving with my NPV as 87,256. Here again I am just going to substitute the values in the formula. It is nothing but present value of cash inflow minus present value of cash outflow. Instead of present value of cash inflows for that particular year, I'm just using the terminal value. Okay. So the answer is 85,866. Now step 3, we move on to step 3. Step 3 is about computation of IRR, okay, for the terminal value again. So the first step is to find the terminal value. With the help of the terminal value, you're just going to find the net present value and you're going to find the IRR, and finally you're just going to pick the correct project. Okay, so the IRR, we already know that at IRR, present value of cash inflows is equal to present value of cash outflows. Yes, instead of using present value of cash inflows of particular years, I'm just going to use what? Terminal cash flows. So the terminal cash flow for project A is for 4,49,854 into 1 plus k power 4. Here under IRR, we already know we are just going to find our rate by ourselves. So I'm just going to use every data here to find my IRR. So I'm just putting k instead of putting any value because I'm just going to find k in this step. So present value of cash outflow is nothing but my investment. So at the end of solving this, I will be arriving with my IRR. So it is nothing but 4,49,859 divided by 2,20,000 is equal to 1 plus k whole power 4. Yeah, so by solving further, my k is going to be, okay, just follow these steps. So by simplifying the step, I'm just arriving with 4th root of 2.045 minus 1. Okay, my IRR for A is, before going further, let me explain how to find the 4th root of 2.045 using a calculator. This format will be useful for you to solve many problems, guys. So calculation of nth root using calculator. Okay, here also I just put it in steps. For the first one is, you're just going to take the root. Okay, just take your calculator and put 2.045 and take root of that. Okay, you're going to press root for what? 12 times. You're just going to press root for 12 times. I'm just going to enter 2.045 and going to take root for 12 times. So I'm just going to subtract 1 from the value arrived in step 1, and after that I'm just going to divide by n, that is n is nothing but your nth root. Here the nth root is nothing but 4, right? So I'm just going to divide the value by 4. Now I will be adding back 1, and finally I will be pressing into an equal to sign for 12 times, with which I will be arriving with my answer. It is nothing but 1.1958. So 1.1958 minus 1 is equal to 19.58 percentage. So this is my IRR for project A. Okay, this is the steps. You just take your calculator and now itself practice that. You will be able to understand that. Okay, let us move further. Now I'm just going to find the IRR for project B. Again, we know that at IRR, present value of cash inflow is equal to present value of cash outflow, and substituting the known values we can able to find our K, right? So same format I'm just using here. Solve everything, guys. So here also you just with the help of the calculator find the fourth root of the value. Then finally you will be arriving with your K, which is nothing but 19.45 percentage. And the final step is nothing but the conclusion. Let us put every values in this page and find how this time disparity works. Okay. So NPV IRR. So NPV for terminal value, IRR for terminal value. Under A, the NPV is nothing but 87,256. For project B, it is nothing but 85,866. So what is the IRR? So it is 19.58 percentage and 19.45 percentage. If you see here, under both the methods, we are getting the same answer. That is, under NPV also, under IRR also, the best project to be chosen is A. So this is how you are going to carry on with your sum when there is a time disparity to avoid the confliction between the normal NPV and IRR. Okay. Okay, by here I'm just going to wrap the section. I will be continuing with life disparity in the next video. Thank you for today.